In one of the previous videos, we were looking at how to use your calculator properly. And what you may have noticed is in a lot of times we put in information in the form of 1.23 times 10 to some power, so like 10 to the, let's say, 5th power. Okay, so in this video, what we're going to do is explore what this means in the context of real numbers and why it's useful for scientists. So this form is known as scientific notation. And it's really, really useful for scientists because it allows us to put very, very large numbers or very, very small numbers into a quickly understandable format. Okay, so for example, if we had a number like 1, 2, 3, 4, 8, 6, 0, 0, 0, 0, 0, 0, 0. Right, so this is a really large number. And by looking at it, it's really tough to figure out just how many decimal places we have, right? So just how many digits we're dealing with. In this case, we're dealing with 3 digits, another 3 digits, another 3 digits, another 3 digits, right? So 100, 1,000, million, billion. So this would be 1,234,860,000,000. So looking at it, it's tough to figure out that this digit is trillion. So what scientists have done is come up with a much more convenient way of writing this really large number. Okay, so what we do is we recognize that the decimal point is positioned here, and basically we just count over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So there's 12 digits, 12 numbers between the position of our decimal place and between the first and the second number. So in this case, we have 12 digits, so we can write this in scientific notation as 1.23486 times 10 to the 12th. So we drop off all of these zeros because by putting times 10 to the 12th, it's implying that those digits are there, and if they're not written, they must be zeros. Okay, so let's look at this from the other perspective. If I have a number like, let's say, 8.6502 times 10 to the 14th. So if I wanted to write this out in longhand form, I know I have 86502. Okay, so starting at this position right here, I move over 14 positions. Okay, so to the 2, that's 1, 2, 3, 4 positions. So we're at 4 here, which means we need to add on another 10 zeros. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digits, and my decimal point actually goes here. Okay, so I have 10 zeros here, and I have another 4 places that were implied from my number 8.6502. So we can write this really large number in a convenient form that shows us that there's 14 digits. Let's look at one more example of this before we examine how to write scientific notation for really small numbers. Okay, so let's say we have something written already in scientific notation that's 2.864 times 10 to the 8th. We can convert this to standard number format. So we have decimal place here, we move over 1, 2, 3 places. So moving over to the 4, that gives us 3 of our 8 places. So we need another 5 zeros. So we have 2.864, that's 3 decimal places, 4, 5, 6, 7, 8. So then I have a comma here, a comma here. So this would be 286,400,000. Okay, so as I mentioned before, we can also use this scientific notation to deal with really small numbers. So for example, if we had our 2.864 times 10 to the negative 8th. Well, now that we have this negative here, this means we're actually moving to the left instead of to the right. Okay, so what I see here is I moved over 1 position, 2 positions, 3, 4, and I need to move another 4. So 5, 6, 7, 8. So I would have 0.0000002864. So in standard notation, this would be 0.0000002864. Okay, we can double check this because we know that if we move this decimal place over 8 positions, it should end up between the 2 and the 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 2.864 times 10 to the minus 8th. Let's try one more. Okay, so what if I give you the number 0.000824? We can convert this into scientific notation. So in this case, I take my decimal place and I move to the right 1, 2, 3, 4 positions. So I have 8.24, and I move the decimal 4 positions over, so it's times 10 to the minus 4th. A really important thing to remember here is that large numbers have positive exponents. So we have something like times 10 to the 8th, right? So anytime this exponent is positive, that means it's a very large number. Anytime your exponent is negative, then that means we have a really small number. So here we have times 10 to the minus 8th, and that means we have a very, very small number. So we move our decimal place to the left.